Now in this video, we're going to do some more problems on dilution. I am not going to solve example problem 13.18 on page 593. And the reason is because I solved a very similar problem by explaining you guys the dilution concept. But I do want to solve example 13.19. And this one here is looks like they do have a certain stock solution, but they do not want to pipette this solution into a different flask to prepare a less concentrated solution or diluted solution. They actually want to prepare now the diluted solution in the same container. So let's see how this is done. So this is what we got here. We got, when you look at the question itself, you see how it says 200.0 milliliters of. You always want to keep these two together. So I'm going to make M1 equals to 1.25 molar. And I'm going to put V1. You see, I keep them, anytime it says off, I'm going to keep them together as the one in this case. If this was the diluted solution, this is more concentrated, this is stock, I would have used M2V2 for these. But what else is given here? Well, they want you now to decrease the original concentration to, you see, M2 now will be equal to 0.770 molar. So what they want you to find out is how much volume you need to add to make this solution. So V kind of 2 we need to find. And then again, if it were just the preparation of the diluted solution in a different flask, I would have just found out the V2. But here, I already have some volume, 200 ml. So they want me to figure out what would be how much of the water I will have to add to make the solution to this same container. So let's see how this is done. Again, I'm going to use M1 times V1, M2, V2. Okay. And so my unknown here is V2. I'm going to just do cross multiplications. Oops. This is supposed to be V1 divided by M2. So let me solve it for V2. I'm going to plot, I'm going to plug 1.25 molar times V1, which is 200.0 ml, divided by M2, which is 0.770 molar. Again, molar cancels out. So I got 3 significant figures here. Is the answer for this particular operation here. 1.25 times 200 divided by 0.770. I got here 325 ml. And this has to be the total volume in the same flask. Okay? If I were to take, for example, prepared my diluted solutions in the previous example, I would have been pretty much adding, my previous example was I pipetted 25 into the flask, and there was 100 total volume. So that would have been adding just 100 minus 25 will be 75 ml. But we usually don't prepare the way the solution, but that's why we use the volumetric flask, because that flask has that certain line. When I add the water to that line, I get exactly 100.0 ml solution. The problem with the adding volumes, if you, for example, have ethanol and you're trying to mix with water, just by adding volumes, you cannot assume that if you add 25 ml of ethanol to 75 of water, you cannot assume that you're going to get 100 ml of the total solution. In fact, you will not get 100 ml. You will get a little bit more. And so that's why we're using what's called volumetric flask. But in this case, they really don't care, looks like, about the volume expansion concept. So they just wanted us to figure out how much we need to add from this 200 ml to 200 ml, how much we need to add to make this solution. And the answer is very simple now. The volume that we need to add, V add is equal to V2 minus, let me see, minus V1, and in this case will be 325 ml minus, let me just get that, 200.0 ml. And again, here you got in the ones precision, here you got in the tens precision. So the final answer must be expressed in the precisions of 1 and to the ones here, and that will be 125 ml must be added to 200 ml to go from 1.25 concentration to 0.770 molar concentration, and that will be the final answer.